Okay, 2.5, solving compound inequalities. A compound inequality is an inequality formed by joining two smaller inequalities with the word and or. Whenever we use the word and, it's called an intersection, and the solutions have to satisfy both inequalities. And inequalities can be written without the word and. And what I mean by that is that we could either list it as this, or it could be listed as this. And the first example we do is going to illustrate that. Next up, we have an or, a union. That's a solution that satisfies either or both, okay? So we're graphing here. And again, this graph is meant to show what an intersection would look like. So starting off with just plain old x is greater than or equal to 2. On a number line, we'd have a 2, we'd have a shaded circle, and we would shade to the right. For next up, for x is less than 7, we would have an open circle on 7, and we would shade to the left. Now, to graph them together, I have it written as one long inequality with two inequality symbols here. So I'm going to draw a longer line here. I'm going to put a 2, maybe a 3, 5, and 7. Or maybe I'll put 6 and 7. That would make more sense. And I'm going to draw them both on the same line. So I have a closed circle on 2, an open circle on 7, 2 shades to the right, 7 shades to the left, so I'm shading the inside of that. Okay? The example that I would give in class would be something like you're buying something at a store, and you want the item to be at least $2, but not $7. So it can be $6.99, but it can't be actually $7. Okay? You've probably seen on Amazon or other online websites where you're buying stuff and you're able to say what the floor and what the ceiling of what you want to pay for. A lot of times it has a little dragging thing for the number line. That's what this reminds me of, right? It has to be at least $2 and no more than $7, so $6.99. So that's an intersection compound inequality. So let's do some more examples. Now I say solve if needed. All of these we're going to have to solve. Number 1 here. We're going to have to solve the x plus 1. We're going to have to subtract 1. Now, because we have two different inequality symbols, we're going to have to actually do this 3 separate times. Right? Because we can kind of see there's like 3 different sides, right? We have like something here, and then we'd have a symbol, something here, a symbol, something there, right? And what I'm saying is that if we subtract from the middle, we have to subtract from both edges as well. So whenever I subtract that, I get negative 4 is less than x is less than 4. So whenever I graph this, I'll put negative 4 here, maybe 0 and 4. I'm going to have an open circle on the left, an open circle on the right. And I always think of this as like a bookend, where negative 4 and 4 are both bookends, and x is in between them. So I shade in the middle. So our actual answer would be the graph and the solved piece there. Next up, number 2. I'm going to need to start off by adding 4 to all 3 sides. That gives me, what is that, 4, 5, 6, 7, negative 3 is less than negative 3w is less than or equal to 6. Now I'm going to divide by negative 3 everywhere. And whenever you divide by a negative number, we have to remember that we have to flip the inequality symbol, right? In this case, we're going to have to flip both inequality symbols. So on the left here, we're going to have a plain old 1, and then we're going to have is greater than, W is greater than or equal to -2. Now I'm going to rewrite this kind of in reverse. That way it goes from smallest to biggest. Because right now, like 1 is the biggest, -2 is the smallest. I'm going to rewrite this as -2 is less than or equal to W is less than 1. Going to a number line, I'll put -2, 0, and 1 on here. I have a closed circle on the -2, an open circle on 1, and I shade the middle. And again, my answer would be this here. You could have used that one right there if you wanted to. Number 3, this one is an OR compound inequality, right? We have the word, we have the word OR. This one, we just have to solve each of them separately. So starting off on the left, I'd subtract 6 from both sides. That would give me 2x is less than -8. I would divide by 2, and x would be less than -4. On the right, I would add 5 to both sides. That would give me 4x is greater than, 5, 6, 7, 8. Dividing by 4, x is larger than 2. So I'm going to draw my number line. I'll have a -4 on it. I'll put 0 on it, and I'll put 2 on it. Starting off at -4, it's going to be an open circle, and it says x is less than, so I'm going to be shading to the left. Then at 2, it's going to be an open circle, and I shade to the right because x is larger than. So you can see that this one, we're saying that we either want the number to be less than 4, or -4, excuse me, or larger than 2. So we have to shade both like the edges. Number 4, I'll start off by subtracting 1 from both sides here. So I have 4x is less than or equal to -12. Dividing by 4, I get x is less than or equal to -3. On the right side here, I'll add 4 to both sides. That'll give me 3x is greater than or equal to 9. So x is greater than or equal to 3. On my number line here, I'll put -3, 0, and 3. They're both going to have a closed circle. It says x is less than or equal to -3, so that's shading on the left here. X is greater than or equal to 3, so shading on the right. And that's that. Now, I want to do 2 special examples. They're kind of unique problems. So that was number 4. This would be number 5. Say that x is greater than 4 and x is greater than 0. So this is an and, so it has to satisfy both. It cannot just satisfy one, it has to satisfy both. So what I'm going to do, just for illustration purposes, I'm going to draw them both separately. Here we'll have 0, and here we'll put 4. I'll do this one in orange. So I'm going to have an open circle on 4, and it's going to be shaded to the right. Right, x is larger than 4. I'll do this one in green, open circle on 0, and I'm also shading to the right. So this one's unique because it's almost just like it's a, I don't know, there are trains and one train's farther behind it. We have to have it to where it covers both of them, not just one, but both. So that's going to only be this space over here. So really, this compound inequality is really just x is greater than 4. It's just x is greater than 4, so we can put our 4, open circle, and we shade on like that. Okay, so that's one of those funky ones to where really it has no, having this and x is greater than 0, that really has no meaning to this, right? It doesn't change the problem. It just makes the problem take a little bit longer. But the answer would be the same as just x is greater than 4. Now, let's look at another example. Oops, this would be number 6, wouldn't it? Oh, but I'm having a hard time remembering this. Let me look at what my example was going to be. Oh, here it is. We'll say x is greater than 4 or x is greater than 0. So this time we're using an or. Or means that it could be the first one, the second one, or both of them. Okay, or both of them. So we have the, sorry, we have the graph right there. So I'm going to look at it for just a second. We want it to cover either of them or both of them. So this time we get to start all the way over here at the left because this one's covered, and then over here it's both of them covered. So this here, we could just say x is greater than 0. In this case, this left piece has no extra meaning to the problem, right? We're looking at the graph that we had right there. So that's kind of the difference between and or. And those are kind of funky problems. There aren't going to be a whole lot of them, but there might be one. And I want you to know how to do that. So we'll go ahead and graph this because x is greater than 0. We'll have -1, 0, and 1, open circle, and shaded to the right. All right, that is that. Good luck on your homework.